I will introduce our work at CVPR 2026 for you, OrienPose, Orientation-Guided Novel View Synthesis for Single-Image Unseen Object Pose Estimation. Estimating the 3D pose often seen objects from a single image remains a fundamental yet challenging problem in computer vision, especially under a CAD model-free setting. Pioneering attempts address this issue by matching templates generated through Novel View Synthesis, NVS, which essentially aims to learn the geometric transformation from a reference to a target view. While promising, these methods can only approximate this transformation under pixel-level supervision, as the starting orientation remains undefined. In the absence of explicit geometric constraints to verify the correctness of the predicted transformation, existing methods often synthesize novel views with geometry-distorted structures or severely blurred local textures, leading to unreliable template matching and suboptimal pose estimation results. To solve this problem, we proposed OrienPose. Our core idea is very straightforward. Instead of letting the model blindly guess the transformation, it is better to provide it with a clear geometric guideline. We used a pre-trained orientation extractor to determine the starting and ending points of the transformation. Then, we designed an orientation consistency loss, which is like giving the model a ruler and telling it, the direction of the newly synthesized view must strictly follow the geometric transformation from the starting point to the ending point. At the same time, we also designed an orientation-aware guidance module, which integrates the orientation information into every layer of the network, allowing it to always consider the geometric rationality when synthesizing images. Contributions are follows. We propose an unseen object 3D pose estimation framework based on orientation-guided novel view synthesis, which requires only a single image without the need for CAD models. We inject explicit orientation priors into reference latent features via an orientation-aware guidance to alleviate the challenge of ill-posed transformation, as well as an orientation consistency loss to handle the lack of explicit geometric constraints during NDS. Our method achieves SOTA performance on multiple benchmarks, demonstrating impressive generalization to unseen objects and considerable robustness to challenging scenarios with occlusion and blur. This is our training framework. First, we use an encoder to extract the features of the reference image. Then, the crucial step comes. Our OAG module will inject the direction information into these features, making them orientation-aware. These enhanced features are then sent to the Novel View Synthesis network to generate the image from the target view. During training, we have two supervision signals. One is the normal pixel-level loss to ensure that the generated image looks realistic. The other is the direction consistency loss we proposed, to ensure that the generated image is geometrically correct. This dual supervision is the key to the success of our method. During the inference stage, for a new query image, we first extract its features. Then, using the pre-trained OrienPose model we have trained, we quickly synthesize a series of template images covering the full viewing angle starting from a reference image. Finally, by comparing the features of these synthesized images with those of the query image, we find the one that matches best, and the corresponding viewing angle is the predicted posture of the object. On ShapeNet, OrienPose consistently outperforms deterministic and generative baselines by introducing stronger orientation-aware cues, which improves novel view control, preserves geometric details, and reduces pose ambiguity, especially for isotropic or weakly textured objects. On Navi, although all methods degrade under zero-shot sim-to-real transfer, OrienPose still achieves the best average performance. These results demonstrate that orientation-aware injection and supervision effectively enhance single-image unseen level pose estimation.